At this time, we need to know that what is the part specification in heat exchanger, because we need to think about the thermal design regarding to heat exchanger detail and parts. Therefore, the first part we are talking about this subject is heat exchanger part. The name is tube sheets or tube sheets. One of the major item in heat exchanger is tube sheets. The detailed drawing of heat exchanger is general layout detail. This detailed drawing say to us what is the tube arrangement. On tube sheets. If this is one heat exchanger, shell side, tube sheet available here. This is a tube sheet segment. Generally, for fixed tube sheet, we have two tube sheets. Therefore, for fixed tube heat exchanger, we have front tube sheet and rear tube sheet. Like at AEL and BEM. U-tube heat exchanger or U-type, we have one tube sheet. Like at BEU and AKU. The K is kettle type heat exchanger. Float heat exchanger have a two tube sheet. In type of AES, one is bigger and larger, another is thinner and smaller than front. This part, as the first part, is front tube sheet. This part at the rear tube sheet. The duty of tube sheet is holding plate, holding tubes or supporting tubes. Therefore, tube available here and hold by the two tube sheet for fixed tube sheet. For example, we are talking about the fixed tube sheet. This is a seamless tube. This is a part as the channel part. This part at the rear side. Depend on the our thermal design, we need to put how many passes available in the system. Therefore, for example, this heat exchanger have a one pass. Therefore, the inlet nozzle at the front and outlet nozzle at the rear. Tube sheet hold the tube. In additional, conduct heat exchanger fluid inside the tube. The direction of fluid is conducted to the inside the tube. This is one pass. NPT one pass. And NPS is one. For example, E shell. thermal engineer try to find that the dimension and arrangement of the tube inside the on the tube sheet. Therefore, tube arrangement say to us number of tube and tube layout. Mechanically, tube sheet made from forging or plate. The thickness of tube sheet here. This is the thickness of tube sheet. Mechanical engineering team try to find the material thickness of tube sheet and mechanical specification for heat exchanger. We have two portions. One portion here, temperature, operating temperature, operating pressure. Design temperature, design pressure. In other side, at the shell side, we have operating temperature, operating pressure, design pressure, and design temperature. Therefore, tube sheet affected in two different pressure and temperature. We need to know that what is the metal temperature. Metal temperature study. Software delivered to us the metal temperature. Tube sheet have a two pressure in both sides. Design pressure for the tube side and design pressure on the shell side. As per thermal requirement, we need to model the bending calculation, bending pressure. Mechanical engineering team designed the heat exchanger based on the high pressure. What is the effect of this item to our thermal design? First, when we are see heat exchanger here as a one path, we see one simple circle, the tube available here. Tube on tube sheet will be arranged with pattern and layout. When we see heat exchanger from this part, from here, for one path heat exchanger we see here. This is the idea of tube sheet. The number of tube on tube sheet, which is called tube hole. Therefore, we need to put some drilling procedure to drill the heat exchanger plate or forge item and put tube inside that. Therefore, the bigger hole is tube sheet hole, the smaller hole is tube hole. This is tube OD and this part is tube sheet hole. Which is called phi. OD will be referenced by TEMA standard. TEMA table D7 and D7M. When we are talking about the tube specification in TEMA sheet, we know that what is the OD of tubes. And we need to think in what is the drilling procedure and what is the tube hole on tube sheet. For example, if you are using the OD 19.05 as an OD of tubes, what is the hole of the tube sheet? What is the phi? Standard say to us the tube hole is 19.25 as a fixed drilling or 19.30 as a standard. This drilling, which is called ligament, tube ligament. Tube ligament, that means what is the tube hole OD on tube sheet based on the tube OD. TEMA standard, as per mechanical requirement for heat exchanger, say to us, please use the drilling philosophy based on the mechanical limitation and specification in TEMA based on the tube OD. Therefore, when we are selecting one tube OD as a thermal designer, the effect of our job is tube hole data and limitation and standard based on the fixed drilling and standard drawing. In future, we are see this document, what is the information of the mechanical teams, and see that what is the information of the standard regarding to fixed and standard ligament. One of the path, this is one tube path. When we have one heat exchanger with two passes, therefore the type provide to here. It is heat exchanger. This is again tube sheet. With channel. If we are using the number of paths of tube 2, we have one additional device and plate here. This is a path partition. Process requirement say to us we need to put nozzle here, follow directly effect on the path partition and through to this portion of the tubes. Therefore, we have two paths. One path available here, second path available here. Flow direction is here. Flow direction is from the left to right and right to left. Therefore, when we are talking about the path, we have additional detail on tube sheet. If we are seeing from here to the tube sheet, we see this detail. One additional recess available here. This is inlet nozzle and outlet nozzle. Path 1 and path 2. This is partition plate location. This item will be groove or path partition groove. This portion is provided by mechanical engineering team and manufacturer, which is called path partition groove, location of path partition. Therefore, the tube sheet divided in two segments. One segment is available top, which is called upper segment, part 1, path 1, and this part is lower segment. Upper segment path 1, for example, and lower segment is path 2. Therefore, we need to provide additional groove in heat exchanger tube sheet for location of path partition. Generally, path partition welded to channel and groove available here. Path partition available here. We have some additional detailed drawing and standard drawing for putting the path partition and installation the path partition inside the channel. In case of the higher path partition tube, higher tube passes, we need to put additional path partition here. For example, if we have 4 paths, number of tube, path is 4, we know that 2 path partition available here. 1 path partition available here. 1 path partition available here. and one tube path available here in case of path partition. One path, two paths, three paths, four paths. Therefore, one path, path 2, 3, and 4. Therefore, the location of the nozzle come here. When we are talking about the tube layout on tube sheet detail drawing, this is provided by the process engineering team. We shall know that number of paths or tube paths and arrangement. We shall know that how many tube available in path 1, number of tube path 1 and number of tube. We shall know that how many tube available in path 2. Based on the TEMA recommendation, when we are designing one heat exchanger, we need to model heat exchanger symmetrically. Symmetrical. That means the number of tube in path 1 shall be equal to number of tube in path 2. For example, if we have 200 total tube requirement as per thermal design calculation, it is mandatory to do the symmetrically for path 2. Number of path 2, we have 100 tube top at the upper segment, 100 tube in below at the lower segment. This is for path 1 and path 2. Generally, we need to model the symmetrically equation. All software like at HTRI, Aspen EDR, or maybe your hand calculation software deliver to us the number of tubes. But we need to generate the path partition detail on the channel, and detail shall be mentioned on the tube sheet layout. Therefore, this tube sheet layout and arrangement available for example, 100 tube. Every tube in top shall be same in bottom. That is the symmetrically tube. It is forbidden to use two different heat exchanger OD, even special items. We are not talking about the special item. TEMA standard say to us, please use one standard tube as a reference. Second, run the heat exchanger and model heat exchanger based on the process requirement and show to us number of tube available on the tube sheet. And if you want to model heat exchanger as a symmetric based on the velocity limitation, it is so important to model heat exchanger symmetrically and generate this drawing to system. Therefore, when we are talking about the fixed tube sheet as a holding tube plate, we need to know that what is the path partition available in channel and what is the path partition available in shell side, in rear channel and front channel. Detail of two tube sheet is different, but the thickness and material is same. Therefore, detail engineering job, we have two detailed drawing, front tube sheet drawing, DWG, and rear tube sheet DWG. Material and type may be same, but the detailed information for the availability of the groove on path partition is different. When we are talking about the 200 tubes in heat exchanger, 200 hole available on first tube sheet and 200 tube available in second tube sheet. But the arrangement and detail and free area is different. This is free area. Free area in heat exchanger say to us the area it is not possible to put the tube. One of the options for increasing the free area heat exchanger that is not possible to put the tube is availability of the path partition. Therefore, when we are talking about the heat exchanger passes, we need to know that what is the installation procedure inside the channel and tube sheet and what is the free area. This free area may be available here. by this segment. We cannot put tube here. It is forbidden. It is not possible to put based on the path partition available here. Therefore, when we are talking about the tube sheet layout say to us how many tube available in system, what is the arrangement of the tube, and what is the drilling philosophy based on the availability of the path partition. We need to know that full layout calculation, full bundle layout. If you see this word in job specification, that means thermal designer try to model heat exchanger by minimizing the free area. Minimize free area. This area we cannot put tube. This is a free area. The philosophy of heat exchanger is we need to provide full layout, bundle, and use all of the surface of tube sheet. Put the tube on the surface of tube sheet to minimize the ID and effective the ID of shell. ID of tube and tube sheet affect ID of the shell. Therefore, if you see the TEMA specification sheet as a summary, we need to know that the shell ID. By shell ID and some additional calculation, we need to generate heat exchanger drawing as a tube sheet ID. That means tube sheet ID. It's so important to check this item. Please consider we are stay here and see the inside the tube sheet and heat exchanger. We see this face. By ability of the path partition, we see the tube and we see the some additional equipment and part available on tube sheet. Tube sheet layout say to us, see the tube sheet and how many tube, how many tie rod, how many path partition available, what is the free area, what is the location of the additional part. Therefore, detailed drawing generated and say to us all of information. Tube sheet philosophy is equal to tube sheet thickness and equal material. We have two material, one material available here, one material available here. Two different design pressure of the shell side, design pressure of the tube side. Therefore, one of the biggest job is selection of the thickness and material. This is the duty of the mechanical engineering team. For better understanding, we need to see one screenshot and report of heat exchanger design in my laptop. Please come with me and see this item.